Okay, so ito yung next example natin. Continuation ng previous video. Then, this problem is from, teka, check ko lang yung aking PDF. Ayun, Engineering Fluid Mechanics by Donald F. Elger and Barbara Williams and Clayton Crow. Okay, so anyway, uh, may kulang na isang ano dito. Given. So this is 3 meters. Okay. So the gate shown is rectangular and has dimensions 6 by 4 meters. So 6 meters, then 4 meters is perpendicular dito sa ating screen. Okay. So what is the reaction at point A? Okay. So ano natin dito, nandito yung ating parang ito yung gate natin, no? Oops. Okay. So this is 4 meters, this is 6. Okay, so hinahanap is reaction at point A. So neglecting the weight of the gate, so ang only force acting dito sa gate natin is yung ating hydrostatic force which acts uh, below yung center of gravity natin. So yan yung force F. Then let's say ito yung ating, okay, so yan yung ating CG. So nandito yung ating, so that is CP, center of pressure. Okay, so since yung hydrostatic force is laging perpendicular ang application sa surface natin, then again, neglecting yung weight, so wala naman tayong downward force, then we expect na yung reaction sa point A should be perpendicular din. Okay. Okay, so yun lang naman ako kontra doon. So meron tayo ngayon ditong ito, natin reaction. So ito yung reaction sa A. Okay, so para ma-solve natin yung reaction sa point A, so kailangan muna natin makuha yung force F and yung distance nung F, siguro mula dito sa base, no? So kailangan natin makuha tong distance na to. Pero before natin makuha yan, okay, so pwedeng solve muna natin yung ating distance E. So yung distance ng center of pressure papunta dun sa or from center of area or center of gravity or centroid. Okay. So first, kunin natin yung force F. Okay. Okay. So force F is equal to, that's unit weight times h bar. Okay. And yung ating area. So ulitin ko lang, no? So ito is yung pressure natin sa center of gravity. Okay. So kunin mo lang yung pressure dun sa may ating center of gravity. So h bar is vertical distance mula dito sa ating centroid. Okay. So meron tayong 3 meters dito. Then kailangan din natin tong distance na to. Okay. So meron tayong triangle ngayon dito, no? Okay, then ito yung ating angle na 30 degrees. Okay. So adjacent side ng triangle, adjacent sa angle, and ito yung ating hypotenuse which is equal to 3 meters. Okay. So this one is, let's say this is distance y. So yung distance y natin is 3 meters cosine, dahil adjacent, cosine ng 30 degrees. Okay, so solving dito sa ating force, unit weight standard natin, na unit weight ng water is 9.81. kilonewton per cubic meter multiplied by yung ating h bar. So, h bar is vertical distance papuntang centroid from liquid surface. So, meron tayong 3 meters plus 3 meters cosine 30 degrees. Okay? So, etong dalawa na to. So, yan yung ating pressure sa center of gravity. Then, multiply natin ng, sa pressure, multiply natin ng area. So, area natin is 6 by 4 meters. Okay, so, of course, meter to, meter, so meter cube over meter cube. So, cancel na lahat ng meters natin. So, makukuha nating force, 9.81. Clear lang muna natin. Okay. So, 9.81 times 3 plus 3 cosine 30. Okay. Then, times 6 times 4. Okay, so we have force is 1,318.01 kilonewton. Okay. So next yung distance E. So yung formula, again, formula natin sa distance E is that is ICG, moment of inertia about the centroid over area y bar. So yung y bar natin, okay, is yung distance natin along the plane. Okay. So along the plane. So kung i-extend natin to, okay. So kailangan natin makuha yung distance na yan. So meron tayong triangle. Okay, so ito yung ating triangle. Ito pa rin yung ating 30 degrees. Mahirap lang talaga mag-drawing sa sa tablet. Okay, so kailangan natin tong distance, let's say, distance x na lang. Okay. So meron tayong adjacent or, again, cosine 30 degrees is equal to, so adjacent natin is 3 meters over ng distance x. Then yung distance x na hinahanap natin is 3 meters over cosine 30 degrees. Okay. So makuha na natin yung y. ICG is BH cube over 12. Okay. So again, konting review lang. Pagka rectangle, about, let's say ito yung kanyang about this axis, no? Okay. So formula natin is BH cube over 12, where yung B is, let's say this is x-axis. Okay. So yung B natin is yung yung parallel sa axis kung saan tayo nagmo-moment of inertia. And then itong axis ng moment of inertia natin, okay, nakatagilid lang siya dito, no? Pero kung titingnan natin dito sa side view, yung axis na yan is naka-perpendicular dito sa screen natin. Okay? So hindi siya naka-incline na ganyan talaga. So yung axis natin sa moment of inertia is actually parallel din siya dito sa liquid surface. Okay? Parallel kasi itong liquid surface natin is meron din yung depth na perpendicular din dito sa screen natin. Okay? So again, dito tayo nagmo-moment of inertia about this axis. So pag tinignan natin dito sa ganitong view, so ito yung ating B, parallel doon. So B, then ito yung height or H. Okay. So solve na natin yung ating um, distance E. So ICG is, B natin is 4 meters, H natin is 6 meters, cube over 12. Okay? So ito yung ating ICG. Over area, area natin is 4 meters by 6 meters. Okay? And ating Y bar. So ano yung ating Y bar? So Y bar again from centroid along the plane papuntang liquid surface. So that is yung distance x plus itong 3 meters. So yung distance x natin is 3 meters over cosine 30, okay, plus 3 meters. So we can solve for distance E. Okay. So we have, actually pwede naman natin simplify muna, no? So cancel natin yung 4. Alisin natin yung isang 6 meters. So magiging square na lang to. Okay. Okay, so solving for E, we have 6 squared over, so we have 12 times, cancel na yung 4 and 6. Then we have 3 over cosine 30 plus 3 meters. Okay. Ups, mali. Ayan. So, plus 3. So, simplify natin. Okay. So, we have 0, 0.4641 meter from the centroid. Okay. So, pwede na natin ngayong mas-solve yung ating reaction sa A. So, we will have to take our moment. So, let's say this is, let's say na lang, no, na this is point B. Okay. So, solving for reactions A, so we have to get the summation of moment at point B. And then that should be equal to 0. So, um, let's take counterclockwise to be positive na lang. Okay. So, yung reaction sa point A, distance natin is 6 meters. Okay, counterclockwise. Okay, so counterclockwise about point B. Then, yung moments about point B ng force F is clockwise direction. So, consider natin yan as negative. So, minus ng force F na 1318.01 kilonewton. Then, yung ating moment arm is, so kalahati is 3 meters, then minus natin yung distance E. Okay, so, ito lang yung kailangan nating distance. So, yung 3 meters, babawasan natin ng distance E na 0.4641 meter. And this is equal to 0. So, pwede na nating solve yung reaction sa point A. So, tatranspose lang naman natin to, no? Papunta sa kabilang side. Okay. So, we will have 1318.01 times a quantity of 3 minus 0.4641. Okay? So, na-transpose natin ito isang term na to. Nilagyan natin sa kabilang side. Then, saka natin i-divide nitong. Okay? So, saka natin i-divide ng 6 meters. Okay? Ayan. Okay. So, ito is lilipat natin sa kabilang side. Then, saka natin siya i-divide ng 6 meters. then divided by 6. Oops, may napindot pala dito. Escape. So, wala na tong 566. Okay. So, we have 557.06 kilonewton. Okay. So, we're done with example number 2. So, example number 2 kasi yung first, yung nakarang video natin. So, tatlo yun, pero kumbaga isang problem lang, no? So, discuss na natin yung different scenarios. So, kung hindi nyo napanood yun, so, search nyo lang yung part 2, itong hydrostatic force on plane surface. So, ang diniscuss ko kasi doon yung um, hanggang ibabaw lang nung gate yung liquid. So, yung nakasubmerge na siya katulad nito. Then, dalawang layer ng liquid sa ibabaw nung gate. And then, yung interface ng dalawang liquid is nasa gitna naman ng gate. Yan, so, different scenarios na yun. Okay, so let's proceed dito sa ating last example. Okay, so, the square gate shown is centrically pivoted or pivoted so that it automatically opens at a certain value of h. Okay, so what is the value in terms of L? So square daw. So this is L. So perpendicular is L then. So tulad nung na-discuss ko doon um, sa previous video natin, sa second part 2 ng hydrostatic force on plane surface. So habang lumalalim yung depth, tumataas. Okay. So kung ito yung centroid ng area natin somewhere dito. Okay. Yung distance in natin is lumiliit. Okay. Okay, so distance E. Not necessarily itong hinge na. Okay? Or habang tumataas yung H, so tumataas din yung location ng hydrostatic force. Okay? So na-discuss na natin yan nung previous video. Okay, so habang tumataas daw at up to a certain height H, so kung sana mag-open yung gate natin. So sabihin, kung mababa pa kasi yung let's say hanggang dito lang yung tubig natin, yung liquid. Okay? So kung hanggang dyan lang yung liquid surface, ang pressure natin is triangular. Okay? Then square yan. So kapag square, tulad ng diniscuss ko ng previous video, um, pwede na tong, so we can determine agad na yung location ng force F is 1/3 nitong height or nitong L. Okay? So that will be 1/3 ng L. If yung liquid surface is hanggang doon sa may ibabaw ng gate. Okay? Then habang tumataas, let's say ito yung, let's say ito yung gitna, no? Somewhere dito. Okay. So habang tumataas yung liquid surface natin, so yung force F natin is tumataas din or yung distance E natin is paliit. Okay, up to a certain height H, then yung hydrostatic force natin is sabi nating okay, just slightly above nitong pivot natin para may open niya ngayon yung gate. Okay? So sabihin yung limit ng force F natin is hanggang dito sa may hinge. Okay? So paano natin makukuha yung ating force, yung height H? Okay. So Again, let's say nandito yung ating center, center of gravity. Okay? Then yung distance E natin is, if this is 0.4, then yung distance E natin is what? 0. So yung distance E is 0.1. Okay? 0.1 ng L, yung distance L. Okay? Or ng length. So, sabihin, if we take yung moment of inertia over area y bar, so that will be equal to 0.1 L. Okay, then yung ating moment of inertia is bh cubed over 12. So b natin is L, perpendicular dito dahil nga square yan. H natin is L din, L cube over 12. Area natin is L squared, dahil nga square. Then yung ating y bar is from center of gravity papunta dun sa taas. Okay? So ano yun? That is H plus itong kalahati ng L or 0.5 L. Okay? So that is equal to 0.1 L. Okay, and then cancel natin yung i-simplify natin. So alisin natin yung L squared dito. So magiging L na lang yan. L minus 2. So L squared pa rin. Okay. And then, meron pa tayong isang L dun sa kabila. Okay. So, pag dinivide pa natin to ng L para lang mas malinaw, no? So, pwede tayo maglagay din ng L din dito sa kabila. So, pwede na natin cancelin totally to. Okay, so simplify natin. So, we will have L over 12. So, ito, pwede natin itong term na to, no? Nasa loob ng parenthesis, lipat natin doon. So, we will have H plus 0.5 L. 0.1 is 1 over 10. Okay? So, i-rearrange pa natin. Lipat ko to doon sa kabilang side. Okay? So, magiging 10L over 12. Tapos, pwede na natin ngayon itong, pag nailipat na natin ito sa kabilang side, na-transpose na natin. Multiply natin ng 10 dito. Multiply natin ng 10 yung nasa left side. Okay? So, para mailipat lang natin siya doon. Then, this will be equal to, minus muna natin yung minus 0.5 L is L over 2, which is equals to H. Then yung height H natin, kung gagawin natin 12, L over 2 is 6 over 12. Tama? So, magiging 6 over 12. So, 10 L over 12 minus 6L over 12. That's L over 2, 1 half. Okay, then we can now solve for H equal to 4 over 12 L or L over 3 or 1/3 L. Okay, so kapag pala, so hindi lang naka-proportion tong ano, no? Yung drawing. So, approximately, mga pag umabot na dito yung, yan, so somewhere dyan, or maybe a little higher. Yan, so, pag umabot na dyan yung water level natin, then, yan, so mag-open na ngayon yung ating gate. Okay, so that's it for hydrostatic force on plane surface. So, marami pa examples dyan. So, try nyo na lang, no? Yung mga nasa mga review books natin. Okay, and kung meron kayong example na gustong isolve, gawa natin ng solution dito sa YouTube, then i-comment nyo lang. So, hanapan natin ng time para gawa ng video. Okay, so if you like this video, please subscribe lang po. So marami pa akong gustong gawing hindi lang fluid mechanics. So in the future, hopefully maka-cover din ako ng statics, engineering mechanics, statics, dynamics, strength, then pataas na subjects. Okay, so that's it for tonight. Then see you again soon.